Okay, let's continue to talk about domain and range and some basics of functions. Here it's asking us to find domain and range again, but this time we're finding it with a graph. So, quick reminder, domain is your x values, aka side to side. Range is your y values, aka up and down. So I'm going to look at this graph and think, what are the x values that are used in this graph? So if I look right here, it looks like the first x value is right here at x equals 1. And then this graph is going to hit every x value going forever and ever to the left. Meaning that if I were to take any point on here and look at the x value of that point, it's going to be one of these x values. So how do we say that? Well, I want to say forever and ever and ever to the left. One way we say that is negative infinity, forever and ever to the left. Then I want to go up to the x value of 1. That's the biggest x value I want to go to. Now we need to do parentheses and brackets. Parenthesis means not included. Bracket means included. Another way of saying this is a parenthesis is a greater than or less than. A bracket is a greater than or equal to, less than or equal to. That includes that point. Now, infinities always get parentheses because they are a concept, not a number. So you can never actually include infinity. You can't reach it. Now, for the 1, I look over here, there is an open circle, which means I am not going to include that 1. I want a parenthesis. Now, let's look at my range. Look at my y values over here. My range is up and down. So I look up here, the maximum y value I'm getting to here is a 4. That's the highest y value I'm reaching. And it looks like my y values are going to keep going down and down forever and ever. So once again, how do we say this? How do I say down and down forever and ever? Well, that'd be negative infinity because it's down. And then the highest y value I reach is 4. And notice this time I can include 4 because the graph is touching it. So I want to bracket. And once again, infinities get parentheses because you can't include them. So there we have it. There's a graph. Now let's talk about some function notation. One quick thing about this, and this will help you for the rest of this class. Please remember that if it is on the inside, you plug in 4x. Or another way of saying that is you plug it in the place of x. Or replace all the x's with this thing inside. That is if it's inside. You replace all the x's with that thing. If it is outside, you set the whole thing equal to this number and then solve from there. That is the big difference. If it's inside, plug it in for x. If it's outside, set the whole thing equal to. So we're going to come right here. I have negative 1 on the inside. So that means everywhere I see an x, I'm just going to replace the x with a blank set of parentheses. Then, inside those parentheses, I'm going to plug in the negative 1, or replace all the x's with that negative 1. Now I can just go about simplifying. Remember order of operations, take care of the exponent first. So negative 1 squared is a, but then I have that negative 1 outside, that makes it a negative again. 3 times negative 1 minus 3 plus 4, that's negative 4 plus 4. Ta-da! Answer is 0. So, understanding that, those basics, I want you to practice B, C, D, and E. So plug in 0, plug in 2, plug in A, and plug in A plus 2. So I want you to pause the video right now, try those 4 on your own, and then come back to check your answer and see how you did. Let's see how you did. So, first one, I got an answer of 4. For C, I got an answer of 6. For D, I got this expression as my answer, negative a squared plus 3a plus 4. Now, on those 3, if you made any sort of mistakes, it may have happened because you didn't do the parentheses. I know that's a very little thing, but if you get in the habit of putting parentheses anytime you plug something in, it will help you avoid a lot of common mistakes. Now, this one, we plugged the a plus 2 in for the x's. So far, so good. Now, something I would like to remind you of. Please remember that a plus 2 squared is not a squared plus 4. You cannot distribute exponents like that because a plus 2 squared is a plus 2 times a plus 2, which means I have to FOIL or distribute. Multiply that out to get this. So please be careful when you have those exponents that you're doing it the right way and not making this middle term disappear. Don't try to distribute exponents. Okay, next I distributed that 3 in to get 3a plus 6. Combined the 6 and the 4 to get the 10. Once I had that FOILed out, then I distributed the negative in front. Why did I do that? Remember, order of operations. I had to square it before I took care of the negative. Distributed that negative in, and finally combined it all. Okay, last one, F. Let's solve. Now, we've already said if it's on the outside, we want to set the whole equation equal to this. So I'm going to take this whole equation and set it equal to this 4. So I set it equal, same, same. Now I'll solve. Now we're going to solve a ton of quadratics this semester. You should have solved quadratics before. Quadratic is anything where the biggest exponent is a squared. If you are trying to solve a quadratic, the only way to go is to bring everything to one side and solve from there, whether it's by factoring or quadratic formula or any of those other things. But that is always how we solve quadratics. So we have a quadratic, highest exponent of 2. So first step, bring everything to the same side. This quadratic just so happens to work out very nicely for us. So now I can factor this. Notice I don't have any number at the end of this, which means these have a greatest common factor. I can take a negative x out of both of them. Now, when I say negative x, I mean divide by negative x. So here, negative x squared divided by negative x is a single x left. 3x divided by negative x is a negative 3. Now that I have that all factored out and it is equal to 0, I can set both parts equal to 0. If this is all a little foreign to you, don't worry too much. We are going to spend more time on solving quadratics in a little bit. So I set them both equal to 0, solve them. Here's my answer. So, last one we're going to do on function notation, and then we're going to move on to doing some domain by hand. We want to use the graph to determine f of 4. Remember, that 4 is on the inside, meaning it is an x value. So I want to come to this graph, and I want to find where the x value is 4. Now, let's list what that point is. That point is at 4, 0. So there's my x value of 4, y value of 0. If I want to find f of 4, I'm essentially being asked for the y value that goes with this x value. So if I look at my point over here that I wrote out, the y value that goes with that x value is 0. So there we go. Okay, that is all I have to say on function notation. In the next video, like I said, we will look at doing domain by hand.